Hey everyone, this is a recap of the duck and sheep problem so far. What we were told is that the barnyard has only ducks and sheep, and that there are 5 total heads and 14 total legs. Alright, well, we have some information as well, just from our knowledge of barnyard animals, that ducks have 1 head and 2 legs, and that sheep have 1 head and 4 legs. So, with the information we know about duck and sheep, and with the knowledge about how many total heads there are and how many total legs there are, we should be able to figure out how many ducks and how many sheep there are. And a nice way to do this is to just make a chart and to go forward from there with it. So, as you guys probably saw, number of ducks, or sheep, number of ducks, and then based on the information you input here, how many heads would that be, how many legs would that be, and does that match what we're trying to find? So for example, if there were 5 sheep and no ducks, that would be 5 heads, but it would be 20 legs, because each of the 5 sheep have 4 legs each, which would be 20 total legs, and that's too many. So let's try and fill more of this out here. If there are 4 sheep and 1 ducks, that would still be 5 heads, but it would be 16 legs from the sheep and 2 legs from the ducks, which would be 18 legs, which is not what we're looking for. Moving forward, if there are 3 sheep, then 2 ducks, that would still be 5 heads. Each of the 3 sheep have 4 legs, which would be 12 legs from that. But the 2 ducks each have 2 legs, which would be 4 legs from that. That's a total of 16 legs, and that's not going to work. So, next, we could have 2 sheep and 3 ducks. That's still 5 total heads. The 2 sheep would have 8 legs total, and the 3 ducks would have 6 legs total, for a total of 14 legs. That's it. So from here, we can figure out that there must be 2 sheep and 3 ducks total. So that's how we can figure this out. 2 sheep, 3 ducks. And if we wanted to write this, we could say that if S is the number of sheep, and if D is the number of ducks, then S is equal to 2 and D is equal to 3, right? Just using variables to represent that relationship. So that's all well, fine and good, being able to use that chart to make that deduction. But it feels like we should be able to formalize this mathematically. So let's try that out a little bit. And the way we're going to do this is we're going to create equations using S and D. All right, so using the information that we are given about the total number of heads and legs, we can create equations based on S and D. All right, so the first piece of information that we're given is that there are 5 total heads. All right, so between the ducks and the sheep, there are 5 total heads. So, well, each sheep has 1 head and each duck has 1 head. So that means that S plus D should equal 5. Right? Because each sheep brings 1 head with it, each duck brings 1 head with it, and we know that there are 5 total heads. Sweet. So that's one equation that will help us describe the situation, the head equation. Now I gotta get to the leg equation. All right, well, we know that there will be S number of sheep, and each of those sheep have 4 legs. So if we multiply the number of sheep by 4, that'll get us the number of legs in sheep. Similarly, we know that there are going to be ducks, and each duck has 2 legs. So we can multiply the number of ducks by 2 to get the total number of legs from ducks. We know that the legs from the sheep and the legs from the duck has to equal 14. So these are our 2 equations that can describe the situation. S plus D equals 5 to describe the total number of heads, and 4